Yes, I'm ready. Okay, six. Okay, now we start. Welcome everyone to the IETF-ROLL interim meeting. Um, Thank you for joining to us. Next slides, please. Please notice that this meeting is agreed with the note well. Read carefully. Next slides. These are the meeting materials. Please volunteer for the code-EMD to take notes. And the other materials are in the links posted. Next slide. So this is the agenda for today. Now in 5 minutes, we proceed with the working group status. Then we have Michael with enrollment priority, Conrad with the new work, and then Pascal with our projection. And at the end, the open floor. Next slides. Okay, the state of the active internet draft. Since last time, we have published the 4 RFC. It is very good. Then we are going to discuss today about the projection and enrollment priority, and we have some work in progress, and the NC extension was submitted for the ISG, and the OTV REPL is a discussion with the ISG. So Charlie is answering the emails, and some feedback is gotten. Next slides, please. About the related internet draft, we are going to have a newcomer, Conrad. Thank you very much for joining us and for presenting your work to detect the crash in the route. And then the 6550 bits draft is open to work. For now, it's a standby, but we have to put more effort on that too. Next slide, please. So about the expired intent draft, we have root acknowledge that we issue a adoption for code on January, but we have not gotten any reply. So a question for you would be like, do you want to work? Should we issue the adoption email again? What do you think? Okay, no, yeah.
Well, the role is not in the meeting, so I guess he has an opinion on that.
Yes, so probably we will drive an email to the community and ask.
We can ask anyway for those who participate in this meeting. Was there an issue with this draft? Any reason why no interest was shown?
Remember the draft.
Michael.
I don't remember the draft, so I should read it again.
Okay.
It's an ACK, end-to-end ACK, when the end device sends a DAO to the root, because the DAO ACKs are hop by hop. Does that ring a bell?
Sounds familiar, and it sure sounds like a good idea. So
okay. Just revive it.
Yeah.
Okay, we'll do that.
And then the lighting diode information and this modification are going to be continued later. And we have 2 works that we don't know how to proceed with the MPL, Young, and the VR Comcast. So those we suppose are going to be continued later. And as well, one comment about ODB Ripple, it's like to implement the Young for that. So that will be as well new work to consider. Okay, 1 minute. So next slides.
Oh, okay. Somebody's typing role in Pascal on the WebEx. I missed the switch to Miteco. Yeah, we originally had a WebEx scheduled, and then we changed it to a Miteco.
Yes, and it's in the materials. we have.
Yeah, if they follow the links, this has changed. So anyway, we can contact them.
Yes.
Are they on Jabber?
I think the chat, yeah.
Okay. Okay, that's another issue. Alvaro can't hear you for some reason. Okay, how do we get Raul and Pascal efficiently in this meeting?
They are in WebEx?
Yeah, apparently. Somebody wrote, I don't know who wrote, but... Let me try email just in case.
The old link. Do you have the old link?
Link. Okay. So we should proceed with the next slide, or hi, Pascal is there, and Raul. Yeah, great. They are connected now. Hi, Pascal. Hi, Raul.
Glad to have you back.
Hello, Ines. Yes, because the last link you sent at the WebEx again, so I joined the WebEx and then found that we were quite alone on it. So I checked on the Codim, see if people were acting, and yes, so I looked down because I thought I remember there was a Mythico somewhere.
Okay, sorry if anything happened. Now we have Alvaro having audio issues. He says he can't hear Ines.
Can you hear me, Alvaro? I'm okay now. He's okay now.
Is he?
Yeah, in the chat.
Oh, okay. Very good.
Great. Okay, next slide. We were discussing about the expert internet draft. Raul, about this road acknowledged draft that we made a call for adoption on January. We have not got any reply, so we plan. Yes, Raul.
Yeah, so I was just going to say the same thing. Since we haven't got any interest in specific replies, so I've let it expire for now. Maybe we can take it up later.
Yeah, we can send a mail to the mailing list and ask.
Well, then first republish it so we have something to refer to, and we'll stir interest again.
Sure. So is the suggestion to republish it with an updated version and check again? I can do that.
Yes, please. So it's live.
Will do.
Thank you.
Thank you. Okay, next slide.
Did you want to ask Pascal about the BR and
yes,
stuff?
Pascal, about this BR Comcast draft that you're going to work with the Karsten, I think.
Yeah, I mean, I have other priorities, so it's just that I cannot work on it, and I have not seen any strong requirement for this at the time. So it's cool technology, very cool technology, but not a priority.
Yeah, at the time we put this in, we actually had an implementation effort, and that seems to have gone away. And I would be a little bit more comfortable with completing this if we do have an ongoing implementation effort. So my personal status for this is waiting for implementation.
Okay. Thanks for your feedback.
And then Ines, I'm sorry, I think we missed something. We wanted to ask Alvaro about the NSA extension.
Yes, Alvaro, we have submitted to the ISG this NC extension. Just to let you know if it's, do you have some update?
Hey, no, I don't have an update. It's sitting in my queue. I'll get to it. I'll get to it soon.
Okay, fair enough.
Thank you. And then, yes. Okay, we have at the one milestone, the NCA extension submitted to the SG. Next slide, that we already are very. Next slides, please. Yeah, thank you. And then for the milestones, we made the recharter if we integrate the contract proposal. Then we have to split the milestone of mopeds and capabilities in two, and then update the date from other ones. And about the Young and Comcast, yeah, we probably have to discuss with Dominic what to do. We can keep them for now and update the date as well. Okay. Next slide, please. Okay, this is the open tickets. Next slide. I think we can jump to Michael. Yeah, well, this is the summary of the today's presentation, but we jump directly with Michael. Thank you. Michael?
Hello.
Hello.
Okay, so I guess I kind of thought this document was done and some issues were raised. And so I guess we need to figure out whether these are real issues or not, and whether we need to fix them. So how? So next slide, please. So this document is about helping behavior that was written up in 6TiSH in RFC 9032, finally published. And this is that document is on the enhanced beacon. And the enhanced beacon, it serves a number of different purposes. One of which is to synchronize in the 6TiSH space the schedule. Another one is to in this document 9032 is to provide enough information for devices that need to enroll or onboard to the network. And a third thing was added to that enhanced beacon, which was for devices which may have already unrolled and which have been sleeping and have lost their synchronization. They will synchronize with the beacon using that, but they also.
Okay, I lost Michael.
I did too.
Oh, Michael, we lost you. Okay, he's connecting. Not hear you, Michael. Okay, I cannot hear you.
Okay, the video.
Now, yes.
All right.
That's fine.
So anyway, so there was a whole bunch of things that 9032 assumes, and one of them is a role priority. Next slide, please. Actually, this is probably a better way to go through. So this is the enhanced beacon from 9032. There's this proxy priority, in which the lower numbers are better. There's a rank priority. The rank is something that the local node knows. It's the Ripple rank, and it's locally known as to what it is. It doesn't need to be communicated there. There's a pan priority. It's unclear how it would be configured, but I believe it would be constant across the entire DODAG. And so, in fact, I think could be added to 9031 if we needed to do that. The join proxy interface ID is present if there is the L2 and L3 addresses are not the same, or not the, that is, if the L3 is not derived from the L2, then we need to transmit what the L3 address is in the enhanced beacon. And the network ID is calculated from the DODAG ID. So everything in this 6-tish object is known except for the priority of the join proxy. And so that's what this document is about, is primarily about. So next slide, please. So the here's an example DODAG, and here's a bunch of enhanced beacons that are being emitted, and they have a different join priority. Some of them are 22, hex 22, some of them are hex 52, some of them are hex 7F, which means infinity, don't join, and some of them are, one of those hex 72. Okay, so this is essentially how do we get this, and there's some slides that we talked about in which I don't want to go through again unless we need to, which explain how this propagated through the network and how it was added to it. Next slide, please. So we have the minimum enrollment priority. This is a metric, and this was added in this document. And then we merged in this other document that wanted to communicate about the total DODAG size. And that is not, the DODAG size is not expressed into the enhanced beacon because essentially, as I understand it, this is something that will be used to decide which of many possible parents and many possible PAN IDs you're going to do, but that it's not involved in enrollment, so it would happen only after enrollment. So we don't need it in the beacon. Next slide, please. So the issues that came up with the review was that the trickle timer means that the DIOs are not sent if there's no topology change. So the question is, would changes to the minimum priority be considered a change from the trickle point of view? Because if that is the case, then if that value would change, then a DIO would be emitted, and unless that caused some devices to change things, there should be no topology changes, but that the DIO change should be, if it changes, observed to change, then there should be new DIOs. The DODAG size field could change quite often, particularly during a network formation. So the question is that something that we also want to be able to propagate quickly or not? So if we do reset the trickle timer, if we don't reset the trickle timer, then we need to put this option in some other thing which is flooded in a better way. And if so, we're going to be creating essentially a new ICMP message of some kind that is going to be flooded. And what other things would we put in it is the question. So that's, I think, the conversation for today. And I think that's the last slide. Next slide, please. I think the last discussion. Yeah. So that's really the question is are we going to, do we want to leave this in the DIO? And if so, do we want to cause a trickle timer reset, or do we want to put it into a new place? Yeah, thanks for going back to that slide. That's the question. Pascal, go ahead.
Okay, so I think before we call those things changes, we have to discuss whether as the message goes down, the nodes are allowed to modify, in particular right now, the minimum priority. I think the original intention was like that, but yes, we've had this recent discussion, and I really changed my mind completely about it. And I think that the min priority should be global to the DODAG, and same for the DODAG size. It's up to the root to decide when it changes it. And when the root changes it, yes, it should cause trickle. reset. But hopefully the root will control how often it does that. And yes, it should be propagated as soon as possible. So yeah, the node should learn that there is a new value. And I think part of the discussion we had is that we need to sequence those things so we know which one is newer. And so basically a node which has the new value should reset its trickle, and a node which has an older value should learn the new value and refrain from sending if he has the old value or something. So the core discussion is, do we change this? And if we agree that we don't, then that makes this question mostly moot, way simpler. What caused the problem is sorry, go ahead.
No, I want you to finish, and I had a response, but I want Raul to have us kick the can too first.
Okay, I have tons of arguments why I don't want the mean priority to be changed down the DODAG. I don't think it affects RFC 1932. And so I would try to make the case of not changing it down the DODAG and focusing on specifying when the mean priority gets to the device, how, what is the reason for the device to increment it? Because whatever one device does, it should be comparable to what another device does. So those two devices can be compared when we receive both messages, both beacons. I think that's where we should focus.
Can we hear Rahul? Maybe you have a comment on that? You want to join the discussion?
Yes, I would. Can you hear me okay? So,
yes, we do.
So not changing mean priority will dramatically simplify things. But there was one use case that we had discussed before. I just would like to point it out, that if there is an intermediate router who's for some reason, if the resources are exhausted on that router, there should have been some way for that router to specify that for all the neighboring nodes to not join through it. So we won't be able to satisfy that use case, right?
No, we could not already, Raul, because now we are talking about join, right? But first of all, you need to tell me what resources you're talking about. Are you talking about bandwidth? Are you talking about memory? Or are you talking about how many join messages it can carry through? For instance, you could say this parent cannot take more than 6 joins in parallel, right?
Yeah.
And if there is a 7, it doesn't have enough buffer to manage the 7th registration.
Correct.
Right? So tell me what resource you're talking about.
That was the use case, actually. The neighbor management was one of the use case where the neighbor table is full, and there should have been some way for the router to.
Yes, but neighbor table is for all neighbors, not the one that are currently joining. We are talking about the nodes that are currently joining.
Right.
If the nodes which already joined, you can't do anything over that. For instance, you have a child which has not joined you, and he wants to, but he's already part of the DODAG, and he wants to move to you as a parent. There is nothing you can do, and this priority doesn't affect that. This priority affects nodes which are not in the DODAG, but what you care about is globally all the children of this parent. So it's not the right thing. That's not this value. I understand your need, but it's not this value.
So I think there's two things. First of all, the local node, when it's a join proxy, can take this minimum priority, and it can add to it a value that reflects how many neighbor entries it has available for joining nodes. So it could wind up at infinity at 7F on its own because it's run out of capacity for being a join proxy, right? So
no, already wrong.
Why?
Because it's not the neighbors. It's just the join. The neighbors are not controlled by this value because the nodes which are already part of the DODAG may move.
I'm not talking about those.
So you're talking about devices which will join this DODAG which are not yet part of the DODAG, right?
So for a node A, if it has no neighbor entries available, or insecure neighbor entries, because it may reserve some for nodes that are already participating. If it has no capacity for new nodes to join, then it could take the minimum priority, which we've specified, which may not be a changing value. It can increment it in some way or make it 7F, and it can emit that in the enhanced beacon, independently of this metric. Yeah,
Michael,
so we all
that
agree
piece we agree.
that is,
yeah.
So, but the point is that
well, we agree with the end of your sentence, not with the beginning. The end of pushing it to 7F because you don't have resource, that's perfectly okay. That's what we always agreed on, and I'm not changing that. What I'm asking you is to consider what makes it move to 7F. So obviously, because say I use you as my joint proxy, right? It's to get the credentials. It might very well be that you will not be the parent I will join. I will share some DIUs. I will run John as well. So I won't be your neighbor in runtime. So what we care about is, for instance, if you need a buffer to store the state during the registration process, and you have only 6 of those buffers, you cannot take 7 registrations in parallel, right?
Right.
So that's what we protect.
Right. But the point is that there may be a difference between I have space for 3 nodes to join and I have space for 6 nodes to join. And so that may be the difference between, 7.0 and 7F. Okay.
Yeah, agreed.
Or something like that. Right. So we agree. And also that if the root sets the min priority to 7F, that no nodes can join.
Yes, that's agreed as well.
Okay. So
yes, what's not agreed is that the current number of children has any effect on it, because it's not controlled by that, and you can.
How quickly can the root set the value to 7F and stop join nodes, or the opposite, right?
That's something we need to discuss separately, because right now we were talking about what affects. I mean, basically, you get this value. Can you increment it down the DODAG? That was the first question. Yes. And the second, and that's what Raul answered, and we are still there. Second, you said, how do you increment it in your beacon depending on your load? Okay, we have to discuss that.
But we agree that it can be incremented by the join proxy in the beacon. So that's
the goal.
That solves a lot of the problem of that we're trying to deal with, without worrying about how does it get to the proxy, right? So we agree that, so what I'm trying to say is that if we make it constant, non-incrementing throughout the DODAG, that we probably still get a fair bit of benefit. Conrad, would you like to contribute something else to this point?
Thank you, Michael. I was going to suggest we wanted to hear him. Go ahead.
Okay, so I don't know about the use cases. However, when it comes to the algorithms, when I wrote this down, it seems that this approach that I called flexible, in which you are able to actually increment your enrollment priority per hop, it's not that much more difficult than the approach with the global. So basically, you just need one additional counter, and the invariant that you maintain is that not the priority of not being equal throughout the DODAG, but greater than or equal to the priority of the roots. So the difference in complexity is not that great.
But that's not the issue, Conrad. The issue is really. It's not
I understand. So I don't know about the requirement, whether
exactly that's the issue.
Whether this would be needed at all. So for that I have no comment. I can imagine that when you have a network such that you have like really precise schedules, then sometimes you would like to disable. So basically, the only case I see is disabling enrollment in a whole sub-DODAG.
But you don't control the shape of the sub-DODAG.
Yeah,
so we are mixing. I mean, a lot of people have been mixing in this discussion the structure of the DODAG, how many children, how much throughput gets through me, which depends on the shape of the DODAG, versus this value. And this value has nothing to do with the shape of the DODAG. It does not control it.
Yeah, it doesn't control the shape of the DODAG. That's true. Yeah.
Actually, it should not at all affect anything routing, because we would be in a very complexity mess if there is any interaction between this and what we already have. So it's very important, and I think we agreed already on the mailing list that this does not affect routing.
Yeah, it shouldn't affect routing. Yeah, that's for something else.
Still, Conrad, sorry. Your comment about sequencing was very useful, and I buy it completely.
No, this sequencing is necessary in either case, so otherwise.
Yeah, it is.
So if we have a global minimum priority, then we don't need an additional lollipop counter, which we would have to put in this object.
Yes, we do.
Is that correct? We still
no,
would
it's
need
wrong.
an additional counter. We
need
that
an
counter.
additional. We need the
Okay,
counter.
so if we add the counter, can we increment down the DODAG?
No, we could, but we don't want to. That's my discussion with Conrad. I want to tell you, you don't want to increment it, whether it's easy or not. And Conrad said, I can make it easier than you think. That's really neat, but it's not what we need. And that's what I hope to demonstrate to you guys today.
Yeah, so we do need a counter even with a global priority. So
we do, because some nodes will be back level, some nodes will be newer. And so when the root updates this value, we want to know it's the latest update.
So, and we can't, making it global doesn't let us attach it to something else that's already in the DIO.
No, it's your option.
Yeah,
I mean,
it's our option.
And actually, we will probably enrich your option as time goes. So it's fine that it's new option. We already enriched it since the draft started.
Right. So, so you were telling me that you would like it to be global, and you had a whole bunch of reasons why this was the case, and
yes.
So I'd like to understand more about that, because it seems to me that
first thing is use cases. First thing is use cases. Basically, think about not just the case where a node joins an arbitrary DODAG, but also the case where a node moves from a DODAG to the next one. And this really we build. That's what we built for Smart Grid. Two different pans.
Yes.
So YSUN, we deploy multiple pans, and our big problem is to balance them.
Yes.
And so when you hear the beacons or read the DIOs for the next DODAG, what you really would like to be able to do is globally decide which of those two DODAGs you want to join. And I think the DODAG priority that you indicated in 1932 could be the exact copy of the mean priority, but that's just me. And then there is, within that DODAG, which one of the possible joint proxies should I use? And that's when the increment from the mean priority to what, goes into
local value, yes.
The local value.
Locally, yeah.
Yeah, that's when it comes into play to allow me, once I have decided which DODAG, which of those particular joint proxies I should use.
Them.
Oh. I still see myself. Somebody can hear me?
Yes, I do.
Yes.
By the way, taking that opportunity, being conscious of time, what is it that we need to do? The three of you seem to understand exactly the issues. So do you think you can carry this over to the mailing list, or do you want to have a meeting dedicated to solving this issue? How can we handle that?
Maybe we can shorten the discussion by asking if there is any use case where you need it incremented down the DODAG.
Yes.
Because if we don't, sorry?
I think this is the main question now. So,
can you solve the question like in 5 minutes, or do you need more time?
We can just ask the question if nobody shows up. I think Raoul did, but I hope I demonstrated that this is not the right value for this. The right value for you, it would be something that controls the shape of the DODAG, not something that controls how many currently joined nodes there are.
No, I didn't want it to, make use of that value to show what exactly the resource requirement on the router is. I just wanted the router to shut off all the other nodes which are keen to join through that router to stop trying.
It shouldn't. I mean, if it is anything, it should be an option which is not which is not impacting trickle, And you'll find that you have to define a lot more than just this value. You will have to define all the properties that go with it, like how you increment it, for what reason, and probably a new objective function, which is not for routing, but for just that purpose, because all the different parents will have to play with the same way, so that one child which needs to choose between parents have to understand,
Sorry, finish it.
I'm saying that there's a lot more work than just having one value. And first, it should not affect trickle. It should not be there. It should be somewhere that we have not defined yet. Second, it's as complex as defining routing itself, defining what you want to do. So balancing the DODAG inside the DODAG by just looking at how loaded my parents are. First, it's not a join problem. It's a runtime problem for nodes already joined. And second, it's a very, very, very hard problem. I don't believe you can even solve it in a distributed fashion. I think it needs to a centralized fashion to do it. But that's just me. But if you find a good algorithm which works asynchronously to balance the structure, tell me about it. I'm interested. So probably it's as transporting a value of any kind in a message is easy. Telling me how to use it to get the result you want, much harder. And if you don't give me the algorithm, I'm not interested in the value. So balancing the DODAG in runtime is a very difficult problem. It's not this draft. And
so do we agree that we have? Do we agree that we have two separate problems that need different solutions? Are we clear on the use case actually? Pascal, you seem to think there are two use cases which require different technologies. Are we in agreement on that? Then the four of us who follow this,
one use case.
The four of you who follow that closely.
Yeah, balancing the DODAG is certainly a different problem. So it shouldn't be solved with enrollment priority, at least in my view. So, I'm still waiting for a compelling use case, like for why we should increase this. Because,
Okay, we agree, Conrad. So if we want to start talking about balancing the DODAG, Raoul, I'm completely open. But all my thought, all my reading, it's a very, very difficult problem. And so let's take it offline.
Sorry.
What I'm a bit hearing is that we don't really know how to turn off enrollment and turn it on enrollment globally.
Yes.
Yes. You can. You said you put the min priority at the root to 7F.
But I don't know how it's going to propagate unless I put intelligently, unless I put another lollipop counter. And I know Raoul doesn't like adding them, and I understand why. So it seems excessive to me to do that.
Why?
And so I'm wondering. I'm wondering
it's because of memory. That's because of static memory.
Flash and memory. Yeah.
Well, if you don't need to store it in Flash, first the I/O, you take it for granted, and from there you will see the updates. So I don't think you need it in Flash.
So if we're okay with that, then the question still arises to me: is putting in the DIO the right answer? Should we have another message that is not subject to trickle, that the root essentially always floods, and that's it, right? If you want it to trickle, put it in the DIO. If you want to do something and you need it to happen immediately, then we have a new message for that.
We don't even have a flood process, Michael.
Okay.
So it's going to be forcing people to implement Meeple or something like that, and some people won't like it.
I guess you're right.
And still, I believe that this is if we agree that it's a one value that the root changes, when it wants. And then after that, it needs to be global to the DODAG. Then it's perfectly fine that it's subject to trickle.
Okay.
And so we just need to add the sequence thing, right? Basically, don't repeat. But basically, learn the new one if the sequence has mounted.
Only.
And I looked at.
The plus is also that if you use this global, let's say, approach, then this is also consistent with the DODAG size, which is it's like everything like really consistent.
So we have to add a lollipop counter to it to keep to allow it to flood properly or to trickle properly, and that we should make it global. All right, so I will accept those recommendations and revise the document.
Please, and this counter would be attached to the whole option, I guess. Anything changes in this option? So. Okay, easier.
Raul?
I tried to look at my old other draft, which looks at sequencing stuff, but it would not really apply here. So I took that idea off. It's not related. We cannot leverage what I had in the other draft. And so it has to be you defining a lollipop here in this option.
Last few minutes on this topic, please.
So, Michael, I'm not much concerned about the resource requirement for handling the sequence counters, because anything that goes into DIO, so anything that goes into DAO, I'm more concerned about, because it involves storing a value in context or routing entry, versus if there is something going from the DIO, it means parent set, and parent set is usually much smaller. So I'm not concerned about it. So just wanted to make, yeah.
Okay, good.
So I'm good there.
Are we all done
if
then?
we have 2 minutes for another subject, we need to work on the logic by which the leaf, the joint proxy, augments the minimum priority to put in the beacon. Do we want to spec it or don't we?
All right, I'm going to propose some text in the document on that, Pascal, and I suggest that it's easier to argue over some piece of text than
so you want to specify?
I think I'm hearing we should specify something. Maybe it's not normative, but we should specify something.
So if we do specify something, we need to be very crisp on what causes this value to change. And in my view, the only thing which is really of interest is, the space for the joint proxy state. The rest is not relevant.
Okay.
We have to discuss that on the mailing list if you don't agree.
Okay.
But number of children or the throughput or anything else, anyway, it's related to the DODAC shape, not to the joint nodes.
I agree.
Okay. So Dominique, we made it.
Yes, thank you. Okay, we can go
Very
to
good.
the...
Yes, sorry, I was distracted for a second.
Next presentation.
That were the backup slides, skipping over them quickly. You guys had a lot of backup.
This is the Conrad already. Yeah.
No. Yeah, no.
This is the Conrad.
Oh, did you say I skipped over?
Yeah,
here we go.
Okay, so this is a new draft. I'm a new member for those that don't know me from the mailing list. So this is a new draft that I wrote sometime in the summer. It gets along with border router crash detection. Can I get next slide, please? Okay, so why do consider LBR crashes in the first place? Well, they play a central role in any LLM, so as DODAC roots. Mostly, they are also for this reason typically more involved than constrained nodes. So they bridge naturally two networks, and they coordinate DODAC construction. So they are more involved both in hardware and software. And in typical deployments, at least those that I had a chance to participate, they usually require a tethered power supply. Sometimes you can back up it, but in many applications, in many deployments, this is very difficult, and you end up with RBRs that are not that have their power supply not backed up. Next slide, please. Next slide. Oh, great. So what happens if we have certain failures in Ripple? And so here you see sort of a mesh network with a border router at the left side. Next slide. So they construct a DODAC, see ranks and links to preferred parent from each of the nodes. Now, next slide, please. So if a link fails, then what normally happens is that a node will detect this. So next slide. And this is the detection. And then it will try to do some local repair. It will try to switch its preferred parent. So for instance, you get the node changing its parent to another node, but also some of its ancestors, descendants in the DODAC also may switch their parents as well as part of local repair. So next slide. So once again, next slide. More tricky situation is when a node fails. In this case, what is actually observed by Ripple is that all links to the node fail. So this means that all nodes, next slide, detect those failures. Actually, it's not necessarily all have to detect them, but only those that use those leaks, depending on a number of factors. But in any case, they would detect the failures of their links, and then next slide, they will also rebuild their let's say, local topology by switching preferred parents, probably also in the sub-DODACs, subtrees descending from the failed node. So next slide. So on the next slide, with a border router, it's more tricky. So if a border router fails, then you can imagine that all links to this border router fail as well. So next slide. And then what should happen is that in fact, no node in the DODAC has any path to the border router, so no path exists globally, so they should all adopt infinite ranks and drop their preferred parents. So they should end up in this situation in which no node actually is able to route any message upwards. From then on, they can do some local stuff like float their own DODACs and so on, but let's leave it for a while. It's just what is important for now is that actually the moment or the algorithm for detecting that the border router is dead. Next slide. So what happens in practice when an LBR crashes? So we did like a lot of experiments with different Ripple implementations, and some stacks, they usually have major bugs. So they enter a chaotic state in which the entire network collapses. So you have an explosion of control traffic, and you cannot route any message anymore. And basically you cannot rebuild anything. Others that have minor bugs, so they do not detect the failure, I mean, in a reasonable time. So what happens is that their ranks grow to infinity, but very, very steadily. So the nodes form routing loops and so on, and in the end, well, you never detect the fact that you have no longer have a path to your LBR, and because of those changes, so they trigger some control traffic that is higher than normal. And some stacks are correct, but in any case, they still require time and control traffic, data traffic as well to detect this LBR crash. Next slide. So why is detecting this LBR crash in Ripple, like plain Ripple, suboptimal? So this is because it relies on the emergent behavior. So first of all, what you have to realize is that all nodes that have links to the dead LBR have to detect that this LBR is dead. Otherwise, if there is some node that still believes that its link to the LBR is alive, so it will advertise a rank that is finite, and then other nodes may join its sub-DODAC. Then, if you take a look at how those link crashes are detected, so this is typically done in a reactive fashion. Ripple recommends that. So if you have low data rate applications, detecting a crash of a link may take a while. So if you have many links to the LBR, then it may take a while to remove all of them. And then finally, so it will just add to your critical path. And then also learning by all nodes that actually no path globally exists to the LBR is also slow and requires control traffic. First of all, because you will have all these local repairs, in which nodes will try to switch parents because the previous parent's rank grew beyond some threshold. Then, since there is no path, such parent changes would likely result in routing loops, and then it takes a while to actually discover a routing loop and break it. And both these, let's say, phenomena also cause trickle timer resets, which imply that you will have increased control traffic. So you will essentially need, depending on your implementation, from tens of seconds to even minutes to actually detect a failure of the LBR, and of course your application and a lot of other factors. So to alleviate this, what we propose is RNFD, which is root node failure detector. Its goal is to minimize time and traffic, just to detect the crash of the LBR. And what we're able to achieve is, let's say, that in terms of time, it's like a few times up to an order of magnitude improvement. In terms of traffic, typically a few times less traffic required. The cost is that you need an additional option in every die, or most of the dies. So next slide, please. So what design principle does this algorithm use? So let's start from the last one. So actually, our goal was to make it completely, or as much independent of Ripple as possible. So this means that it tries not to affect the protocol or the operation of the protocol in any case, just when it's necessary. So for instance, when the failure of the LBR has been detected, then it will affect Ripple in such a way that it will prevent it from adopting any new parents in a particular dollar version. But apart from that, so this algorithm works completely independently in the background. So the first principle is that to expedite this failure detection, it explicitly coordinates monitoring of the LBR between nodes. So this means that the nodes collaborate. So rather than relying on the emergent behavior, they collaborate on detecting the failure of the root, which well, allows for reducing the time that is necessary to detect this failure. Then it also avoids probing all links. So if just sufficiently many links to the LBR are considered as dead, then the algorithm concludes that the LBR has died. So this means that we don't have to wait for this, let's say, stragglers, a couple of nodes that don't route a lot of traffic to detect the failure, and they won't disrupt this whole detection process by advertising finite paths and then forming further routing loops. And then this algorithm also, to further improve this failure detection, it tries to proactively checking for LBR crash when there is a suspicion that it might have happened. Like for instance, if there is some sign that other nodes believe that their links to the LBR are down, then some other node may check whether its link is still up or whether it's also down. So this will also, even if it doesn't route any traffic. So this, okay, so Pascal wants to raise a hand.
Just clarifying question, Conrad, please.
Mm-hmm.
Reading this, I expected that the nodes which would participate to this group of coordinating monitors
Mm-hmm.
would be one hop away from the root, right? So it's just between those guys.
Yes.
Okay.
But well, it's not precise. It's not the precise definition, but it's well, they do most of the job. Okay, but actually, the coordination of everybody is needed because the nodes that are one hop away need not be connected in a single connected graph, so they have to also coordinate.
Well, if the LBR is there, they are, because they can talk through the LBR, right? And since effectively they want to detect that the LBR is down by, randomly pinging one another and getting enough of those ping just through the root would help you a lot, possibly, because it would stop working for everybody. If all the first stops pinging one another, that could help. I'm not sure.
That's also a nice observation. Anyway, okay, so next slide. So we have just two roles. So this algorithm divides nodes into two roles. So the first one is sentinels. So these are the nodes that do most of the job. So they monitor the status of the root. They are the root's neighbors. So to be a sentinel, a node must be a neighbor of the root, but being a root's neighbor doesn't imply that you have to be a sentinel. And the other role is acceptor. So there is any other node that's not sentinel is just an acceptor. So next slide, please. So if you take a look at the previous DODAC, the nodes that are marked with arrows are possible sentinels. So they don't have to be sentinels, but they can be sentinels. They can play these roles. Next slide. Basically, what RNFD uses is two local data structures per node. One is locally observed DODAC root state, called LORS. Basically, just an enum that describes possible states and an observation of any node of the state, the global state of the DODAC root. And then the other structure is CFRC, which is sort of conflict-free replicated counter. It counts sentinels that exhibit certain property. What is important is that two CFRCs can be compared, and this comparison is a partial order, and they can be merged in an order and duplicate in sensitive fashion, which means that if they propagate with diodes, they can be merged in any order. They can be merged multiple times, and you always get the same result. So each node keeps two such CFRCs, one which I call positive CFRC. It counts sentinels that consider their links with the root as down, and then negative positive that consider the link with the root as up, and then negative that consider the link with the root as down, but previously considered it as up. So positive CFRC is always greater than or equal to the negative CFRC. So next slide, please. And then what the protocol adds is one option. So basically, what is important is that you just carry these two CFRCs, so positive CFRC and negative CFRC. These are fields that can have variable length. And upon reception, what you typically do is you just merge the received CFRC with your local ones and then perform some actions. So the whole protocol is not that difficult in a way. So next slide. So this is LORS, the possible values of this enum, and then transitions between them. So I can explain the protocol by actually going through the slide. So next slide, please. So these two states, so up and globally down, are attained by all nodes. So up is a state meaning that everything is okay. So the root, the LBR is up, and down, globally down means that all nodes agree that the root is down and this DODAC should no longer be used. Then you have two intermediate states. They can be attained only by sentinels. So it's suspected down. This means that some sentinel suspects its link to the root being down. And then locally down, this means that the sentinel actually considers its link to the root with down. So this means that it typically verified the link to be down. So next state. Okay, so how this protocol operates. So whenever a node joins a DODAC, whether it's sentinel or acceptor, it sets its state to up, and then its subsequent behavior depends on whether it's sentinel or it's an acceptor. If it's a sentinel, at some point starts suspecting that the root may be down, it can do this suspicion, have these suspicions based on external observation, at the data plane, so like external events like lost hop-by-hop acknowledgement. So this is like implementation specific. Or internal events like local values of CFRCs. Then it transits to this state suspected down, and in this state, it wishes to verify whether its suspicion is justified or not. So next slide, please. So it can perform some verification, for instance, try to send like a ping to the root or whatever. And if it confirms that its link with the root is down, then it transits to the state locally down. and while in this state, it increments its negative CFRC, which aims to trigger other nodes to indicate to other nodes, other sentinels, that something may be happening with the root, so they may wish to decide to perform their own verification of the links with the root. So next slide. Sometimes you may want to skip the verification. So for instance, if your node is doing routing and you are not forwarding to the root, so you are a sentinel and forwarding data to the root, and you don't get any acknowledgements or whatever replies to your pings, then well, you may well believe that your link is indeed down, or simply your neighbor reachability detection claims your link with the root to be down, then transit directly to locally down without this suspected down in between. So next slide, please. Of course, if you get any sign that the root may be up, like for instance, you get a message directly from the root, or you get a reply to your ping, whatever, or your neighbor unreachability detection claims that the root is back up again, then you can transit from locally down to suspected down as a sentinel, to up, and this means that everything went back to normal, at least regarding your link. Next slide. Finally, if sufficiently many sentinels consider the link with their links with the root to be down, then what happens is that any node, in this case, an acceptor or a sentinel, can make a decision that the root must be down. So it transits to globally down and appropriately changes its CFRCs. And then when they propagate in diodes, actually every other node also transits to globally down. And so next slide. While in globally down, so this is a terminal state, meaning that no routing is possible in this particular DODAC. So you can return back to up only when the DODAC root issues a new DODAC version. So this means that you do a complete rebuilding of the DODAC. So basically, this is like a state that says that everything is broken. You shouldn't even attempt any routing because you may have routing loops, and you should like stop it. Yes, Pascal?
Yes, just a clarifying question. You say when sufficient sentinels know, I was wondering how they can communicate if the root is effectively down.
Yeah, exactly. So they don't communicate. So so the whole protocol operates by means of this CFRC merging, and this CFRC is propagating diodes. So the diodes will be transmitted even despite the fact that the root is down, and
they will be transmitting down, right? But it might be that, just to give you an extreme case, I have my root in the middle of a cross, and each of the four directions is a different sentinel.
Yes, yes. So if your network is very sparse, like what you said, you have a cross, and if no part of the cross is actually connected in any way with another part of the cross, then you have two options. One, you can consider sufficiently many as basically, I don't know how many links with the cross you have in your, let's say, so suppose that you have those four network types, so you divide the number of links, the possible number of links with the root by 4, and divided by half.
Yeah, so that boils down to my other question, which I think I asked you earlier, which is, it works based on parameters. Basically, one parameter is how to transit from locally to globally, and those parameters seems to vary between one structure and the next. So makes the protocol very hard to deploy.
So the thing is that they need not vary in let's say, I would say normal networks, in a sense that you have not this extreme case of a cross. Like if you have sufficiently connected network, I'm not claiming that all sentinels have to be connected, but that your network as a whole doesn't have this sort of bridges, removing which actually removes, partitions the network. So most networks have few, if not zero nodes of that type. Otherwise,
I still would suggest, Konrad, that you consider what I told you earlier, which is try to do most of your operations through the root. Like if you trickle through the root, right? Everybody, all the sentinels can send something. And because of trickle, there will be only one. And it's a multicast to all sentinels. And you send it through the root. So after a trickle timeout, there will be 1 or 2 sentinels which will send to all sentinels. And so if you stop receiving that, somehow you reset your trickle timer and you become a lot more aggressive or something.
Okay,
and if there is no hack at the lower layer, because you've become much more aggressive, pulling the root, now you can detect that the root is down. And everybody can do that pretty much at the same time. And that's very important from what you said earlier. You want all the sentinels to detect at the same time, because they will all start sending DIOs with the G bit off or something, and you'll avoid all those ping pongs that you've discussed. So look at the properties you want. That is an important property. All the sentinels, all the first hops really should declare that the root is down pretty much at the same time.
Well, not all of them, but yeah.
Well,
let's say
if you do what I'm, all of them would avoid the churn. If you basically have a group of all first hops, and you send a multicast to all of them through the root. So you send the packet to the root, and the root is supposed to send it to all the first hops. And it's trickled out. So you have 2 every period. And the period is increasing blah. But when the 2 of them don't flow through during one period, all the nodes start sending their own because they are not cancelled, and they don't get lower layer hack. And so ideally that would reset their trickle timer, which is not really trickle. But if basically failure to receive one of the 2 or 3 messages during a period is considered like a problem, then they would aggressively pull all of them would aggressively pull the root. And if that happens, then they will pretty much at the same time declare the root down.
Okay, so
and that's independent of the structure. I don't like the idea that the parameters of the protocol are dependent on the structure. That really hurts me.
Okay, I will think about that. Okay, so off topic, maybe it's not a bad idea actually. I remember that we wanted at some point to have sort of the operation of the protocol independent of it, but let me think about this offline. Okay, so I think that's mostly it. Can we get to the next slide? Okay, so the status is it was submitted on April 6th, and then after discussions with Pascal and Michael mostly, I added a lot of let's say corrections in the GitHub file, and yeah, further contributions are welcome. So in particular, I will think about this communication through the root that Pascal suggested. How it can improve the coordination between sentinels. That may make a lot of sense actually, but yeah.
Think about the property of the protocol that you want to achieve. Like, I really think it's important if you can make it that all the first hops discover almost at the same time. I mean, a very close window. Yeah, so that you know there is no churn in. They start all sending DIOs with G bit off or something, and so people don't join here and join there because they join somebody who still says I can use the root, but it's just because he doesn't know he cannot. That's pretty. Yeah, you would avoid some churn, not all of it, but you would avoid some churn.
Yeah, but okay, so that's true. That's one aspect. So detection. Okay, I know what I wanted to reply. That actually can help still. I think we in the draft that I put it, we moved this communication through the root, which actually out. But I think that the most of the delay gets from the fact that you have like local rebuilding. So basically the propagation of the information down the DODAG, for which you really need those diodes and CFRCs. So they, I think, add most of the latency. So once anybody decides that the root may be down, then what happens is that then this information spreads very quickly. That's one thing. And then the other thing is what we also considered was that the nodes that are one hop away can also be dead, in a sense that for some reason well, they may be dead for some reason, and we didn't want to rely on them being up or not. But okay, but I think this suggestion is nice in a sense that it can complement the detection period by Sentinel, so basically the verification part of the stuff, which is actually left out of the draft. But it may be actually nice to have it as a suggestion of how you can implement this. But the core algorithm relies on quickly propagating this information on the root being down throughout all nodes, so that they don't start forming loops and so on. So I think this is complementary, but let me also think about this offline, okay? Thanks for the suggestion, by the way.
Good. I think there's interest in this work. This is what I collect from the discussion. I think, Michael, you already raised the question on the mailing list where we should adopt this draft. So technically, looking at the charter, it's not quite in our charter. So we would, I don't know how I would pretend it fits in the charter. So we can update the charter anyway. We wanted to do that at some point. And since Conrad is actually a new resource coming with its own topic, I think this shouldn't be too much of a problem. Any comment on that, Alvaro, if you do have audio to speak right now? Going once.
In the chat, is the maintenance of REPL should be in our charter. I agree.
It should be. I don't read that it is. Oh, maintenance in general. Okay.
Yeah, I agree.
So basically,
so when I started my work, there was something in the charter that was related, but then it took me a while to actually do this because of the pandemic. So I think it went off the charter. Just a remark.
Yeah, I don't think it's a big deal anyway, because, I mean, even if it's not strictly written this way, there clearly is an interest. Any more comment from the working group, Pascal, Roll?
Yes, if we adopt it, we need to think about the track. Do you think it's for experiment, or do you think we are going for standard track?
Good point. For a standard track, we need to have several implementations, as it needs to be
not that much, but it seems to me that that's a real problem. We need to solve it. How to solve it, just by the discussion of today, seems to me that we should not rush into a final solution, and probably we'll find that the algorithms can be perfected after several rounds. We had other problems for which we shipped solutions in our fans and found that tuning it, trying different stuff. And so if we standardize it, and after 6 months we find, actually the algorithm needs to be changed, we'll have locked all the records and all, in the messages and blah and blah. And I'm concerned that this is a very difficult topic. We have not looked at it in depth. And so I'm concerned that one early standard track we will have to update it. And updating something in the field is very, very hard. And so, the brown field is very, very hard to update. Because that's
so you're suggesting
backward compatibility, etc. So yes, first it needs to consider backward compatibility, how to be upgraded easily, and backward compatibility, blah. And so right now it's a beautiful algorithm. It needs to account for a lot more. So as an experiment, I'm okay. As a standard track, it will take a lot more thought. Do we want to do it in one shot, or do we want to first do some experiment and then do the real thing? Now, just the question about going through the root or not, but there are other questions like if we need to upgrade something in that algorithm, how does that happen? Because tomorrow we find that, I don't know what, I mean, the parameters, one more parameter, can we do it backward compatible? That's very hard. So the more we understand the problem and the solution, and the more we have experience on the solution, the more we can say, oh, that's the standard, that's how we're going to do it.
Okay, point taken. Being conscious of time, I suggest we move to the next topic in the agenda. And as always, we'll confirm that on the mailing list. And Pascal, your turn. Slightly shorter time than expected, but
yeah, expected though. So I did not put too many. I just focused on one problem. So let me give you an update on where we are. And actually, this update I prepared it almost last minute because sorry, you get chairs for being late, but because we had a lot of discussion on the draft very recently, so I tried to accommodate some of that. I could not accommodate all because we got IOTDR review like 2 days ago. And it's a very big review by Torles, so I can't thank Torles enough. So many thanks. He's not there to listen, but so I started accounting for that, and that's the reason why I did not publish 20. And I saw Dominic, thank you so much that you made a review on 19, but there were a lot of changes due to Anand's review, etc. From 19 to 20. So I'll see how I can apply the diffs, but it will probably not be as easy as I would like it to be. Okay. Anyway, so next slide, please. So yes, 17 to 19, so 3 versions since last interim, which was 6 months ago, I guess, January, was it? And 20 is, I should have published 20 after Anand's review, but that's when Torles' review came in. And sadly, because I should really have done it, because you did your review on 19. So we clarified how you find the sibling address, which was missing. And so now we have more dependency on 9505. And we try to simplify again. And one big simplification we discussed was who can send a PDR. And related is what's the namespace for the track ID. The track ID is the pair of an IP address, which is source or destination of the packets. So it's the track ingress or the track egress, basically. And a number, which is a local instance ID in REPL terms. So it's 64 bits, basically. So you have that space to express yourself. So the simplification is the PDAO request, which is the request by a node in the field to go to the root and say, please build a track for me. Now it can only come from the track ingress, which will be the root of the small DODAG ID, small DODAG. And so it will be, quote unquote, the DODAG ID, and it will also be the namespace associated to the track ID, to the REPL instance ID to form the track ID. So that makes things very simple. So basically node B cannot say, I want a track from A to C. Only A can say, I want a track from A to whatever. So that's the simplification. The naming is simpler. And selecting the 64 bits, not 64 bits, the value 0 to 64, 0 to 63, I'm sorry. So the 6 bits is in the namespace of that node which requests the PDR. So that makes things a lot simpler. A lot of work on maintenance. I mean, Anand really raised the question of what happens when basically there are breakages, etc. So that will be my some slides today, and I just show how it works. It doesn't involve any new stuff, new function. It's just that the text was not really there to explain how it works and what happens, and so it was kind of implicit. Now it's more explicit. What I added as I did that is I added the concept of leg, because that term was missing. When you do a segment is a storing mode strict sequence of nodes. And that's basically between two loose nodes. For instance, when you have the main DODAG and you want to make your source route header loose, sparse, between two hops in the source route header, you need a segment which will allow one hop in the source route header to reach the next hop in the source route header. So that's a storing mode, strict list of nodes between one hop and the next hop of the loose source. So that's what a segment is. It's a storing mode thing. Now, when you don't use the main DODAG for doing your routing headers, you want a non-storing DODAG for being the track. What we can build today with the draft is loose sequence of nodes between the ingress and the egress. So you need to see it as several lines, more or less parallel, between the source and the destination. They can cross, but it's mostly like several lines between source and destination. It's not really a DODAG. That will be the big question that I want to discuss today. What we can build is not really a DODAG. What we can build is really a number of parallel lines. So I call them leg to clarify that. And again, those legs can cross. They can two of them. They can make a 8 instead of 2 parallel lines. But still, it's from source to ingress to egress sequence of nodes. And so, if we really want to do DODAGs, probably we want to add some stuff. But this is already very good because you can do 1 + 1, blah blah blah. Also, I clarified that everything policies is out of scope. It's not part of this document. Again, simplification, because people would see that as, segment routing or something where you have this packet and you want to decide, should I use the main DODAG to forward or should I inject it in the track? So I'm the track ingress, I've got a packet, destination is can be routed through the track egress. Okay, so I have those PDAO, which allow me to get to the track egress directly. But I could still reach through the route if I'm not storing or through the normal storing mode DODAG. So which one should I use? Is there a policy? No, there is no policy. If people want to do policies, it's going to be done somewhere else. All we do is routing. And so if basically you have a route through a track, you will have an entry in your routing table, which will be a longer match than the rest, because the rest is basically default route towards the route in non-storing mode. So basically you'll compare a route to a prefix which is across the track versus default through the route. So every packet which matches a track will always get through a track. So that's basic routing. We don't go beyond that. We don't say packet which match this kind of schema would get into this track or that track or that track. We don't do DetNet. Not in this draft. We just do routing. So it's simplification, clarification. And so big thanks to the review from Anand and Torles. The draft on the GitHub already covers what Anand said, and I'm working on Torles' discussion, and it takes time. It's a very long and very interesting review. Yeah, I think I will go through Torles' review, publish what I get as 20, and then with Torles we'll fix the bugs left, and then we'll have to address this DODAG story that we'll discuss today. Next slide, please. So Anand's review, basically one of his main points was to, how can the route control the DODAG the path of inside the track if he cannot reach the nodes. And so we clarified that a node which belongs to a track should have multiple parents, and so send is DAO to the route, indicating multiple transit, and so that recursively, hopefully that gives us more than one source route path from the route. So if the route has to retry a PDAO, it should retry on a different source route path. So we basically clarified that to improve the reliability of the control. But at the same time, we don't want to build track between the route to the track member, because then who would control those tracks, right? Who guards the guardians, basically. So we don't want to get into a recursive problem. We just want to make it quite reliable. And if there is enough redundancy in the track by having multiple parallel legs, then if something is broken, even if the route is not connecting to all the nodes, it can start repairing. But during that time, we can use what's left to still transfer the packets, using the redundancy to survive before the route can do everything. So clarified but was already there, that the no-path DAO is how we indicate that we remove something, and it's recognized by a lifetime of 0. And we also documented that in storing mode, so when we build segments, we can just change a section of the segment. So when you create the segments, for instance, A to H here, you have to signal in one VIO all the members of the segment. So you see this strict list of nodes, and the PDAO arrives at H, comes across over upstream, basically all the way to A, and A does the acknowledgement. So for the first PDAO, which creates the segments, you need to have every one of them. But when you repair, you see D is broken. I mean, maybe C to D because of interference, and maybe D to G. Well, the path between C and G is really fluctuating at this moment. We want to repair it and go through E and F. Well, when we do that, we just can do a local patch between C and G, and we don't have to resignal the A, B, C, or G, H. So when you repair, when you modify, you can do it on a section of the segment. And if we do, because of the way the PDAOs are done, and now it's explained, it was there all the time, but there is more text to explain how it goes. It can effectively be lossless. The only loss that you'll encounter is the one which were caused by the interference itself, and which triggered possibly the repair. But the process itself will not break and make. It's actually a make before break. So you don't lose packets because of the process itself. And so I'm explaining why in the next slide for a segment, but when you look at the whole track, which has multiple segments joined by source routing, non-storing, you'll see that the same story works as well. So what you'll see here, you can extend to the whole structure for the end-to-end track. So here is the initial prime on this drawing here. You see this interference, and going through D between C and G is problematic. So let's go to next slide. So when the root is aware of that, it will send PDAO. So we are in storing mode here. We are talking about a segment. So the PDAO goes to the end of the repaired section. So that's G. So the beginning and the end of the repaired section must, they must be still attached to. They must not be broken. Basically, you fix what's between them, but those ones are stay attached where they were. Either upstream for C or downstream for G. So the root sends the PDAO to G. Actually, here I said G, F, E, C. The real SRVIO will have them in the reverse order. The way it's encoded, it's in the path order, not the upstream order. So it's kind of a typo for me, if you like, but it clarifies the direction in which it's going. But the way it's encoded would be C, E, F, G, really. So the PDAO goes to G, indicating C, F, G, and so upon that, as it's a storing mode, it will go up the list. So G sends forwards the PDAO to F, and F installs a routing state to G for that track, for that segment. So the PDAO indicates the same segment ID as before, but the segment sequence has been increased by 1, or by whatever. So second drawing, you see that the PDAO is progressing, but not next slide. I was going from first, we are looking at the first picture on the top. Now we are looking at the middle picture. We see that the PDAO is progressing.
Pascal, yeah. Sorry, there's 2 minutes left on the agenda, just in case Miteco shuts down automatically and drops out.
Oh, sorry.
Just make sure you have your main point covered before.
Okay, so
and then if by chance it extends, then you can go back.
Okay. So just look at the picture, and you figure that as the PDAO progresses, the packets still follow the old path. And see if the old path is still operating, not as well, but still operating. The packets are not lost. And when the PDAO reaches C commutes because it is the new segment sequence, it commutes to the upstream path, and you see it's already built all the way to the end, so there is no packet loss. And then there can be another PDAO to just clean D separately with a lifetime of 0. So next slide, please. You think about it, but you see it's non-breaking. So we need to skip that. So I was discussing a track. What I'm saying in this slide basically is we only build multi-legged tracks. We don't build DO DAGs. And this is an example of a multi-leg DAG. track with 2 legs. The first source route path on the top, second source route path is on the bottom, and each of the segment is a storing mode VIO. So what we see is we can take path A or path B. If there is a breakage, you can see the 2 legs, but really it's not a DODAG as we're used to. And the question is, do we want to build real DODAGs? Next slide. By the way, the other thing we don't have, which exists in RAW, is we don't have north-south segments. Because we are working on REPL, we only build DODAGs, so there will never be bidirectional segments. They always go east, left to right, really, which is west to east, sadly, but always go left to right. So this is a non-goal. Next slide. Okay, this is the goal. We would like to be able to have node A or node C decide if they go to E or down, like should C use segment 1 or should C use segment 7 or should C replicate over segment 1 and segment 7. That's if we build a DODAG. That's a real DODAG we would like to build. But with the VIOs, which are sequence of nodes, it's very hard to build. You cannot build that. Next slide. Okay, that's my last slide. So the proposal on the table to really be able to build DODAGs would be to emulate what we do in the main DODAG using transit and targets. So basically, what I could add as one paragraph, basically, or 2, is to say, oh, by the way, if you don't want to use the VIOs, the root can still pack a number of target, transit, target, transit, target, transit, emulating that all the nodes in the new small DODAG, the track, send their own non-storing DAOs to the ingress. So basically doing the exact same thing in the track as we do in the main DODAG, a number of targets and transits, so that now we can build any DODAG structure as we do in the main DODAG. So that's my proposal. If you agree that I do that, then I can add the text of saying, hey, there's also this possibility. And possibly people will really like it. It makes the ingress code more complex because it becomes a root, but it also enables much more topologies. So if our nodes are capable to do what a root does, then this proposal on the table, you could build real DODAGs as opposed to just parallel legs, which is a lot easier, by the way. Okay, so any discussion on that? And that's my last slide.
Thank you for making it nearly on time. Any comments on that? Any suggestions to Pascal?
If I don't get comments, I will just insist on one thing. Building real DODAGs, the root activity here is a lot more complex than the parallel legs that we have for the root, so for the ingress, but it enables row. It enables much more capabilities. So for me, it's really another mode for what we're doing. Because if you look at the parallel legs, what is signaled to the ingress is basically almost the routing header that is going to put in the packets. Very easy. It just takes what's in the DIO, puts it in front of the packet as an encapsulation, and the packets fly. There is no computation, there is nothing. Very easy. If we do what I'm proposing here, or if we standardize it, yes, we know it works because that emulates exactly what we do today in non-storing, but that makes the ingress as complex as a normal root to compute the source route header that you want to use at this time. That's what RAW wants. So it's useful to have it in my mind, but that's probably not what people will implement for pure REPL, as of today for the classical REPL use cases. So that's why it's very good that we have the legs and stuff, but it's good open to the future to also enable this. If we don't do it in this draft, probably I would write another draft to just do that. But I mean, it's just 2 paragraphs or something. So why don't we package it here?
Any comments on that? Sorry, I was typing notes. You said it's much more complex. Do you think this adds risks
the code,
and
the ingress,
delay?
Well, the implementation needs more room, and it needs more computation to be able to operate, because it's going to get what the root gets today, you know, those packs or of this child as those parents. And so he needs to reconstruct the DODAG in his mind. When he wants to go to the egress, he needs to select a path in that DODAG, put it in a source route header, and now we can send. With what we have in VIO, the source route header is pre-built in the DIO. I'm sorry, in the PDAO. It's pre-built. It just picks it, copies it in the packet, bang, it goes over that leg. So the ingress needs a lot more code, but the capabilities are, you go from, you know, plain serial routing, well, you know, just a shortcut in a REPL, but really similar to REPL as today, to something which is capable of doing raw .NET, you know. So, you know, replication elimination, basically, and all those games. So I'm not saying people should implement that today, right? I mean, they should implement what we have in the current draft, but this is a nice addition for the more post to prepare for raw, basically. So should we mention it? Should we not mention it? I don't see that, you know, I'm making this feature optional. I don't see that it hurts that I add the text. But you tell me.
Sorry, I got distracted. I think we are running out of time and Miteco is coming to pieces. I lost the code EMD, hopefully. Everything was captured. Anybody else on the code EMD right now? The whole thing just cleared.
Yeah, I don't see anybody coming to the mic. Would have liked to see Michael or Mathieu.
No, I think it's down. Like I tried to refresh and it's down.
I think it's just the whole session closing automatically, you know, 5 minutes over time. Yep. Anyway, in the US, it's probably the beginning of the day and you have something else to tend to. In Europe, it's probably the end of our day, but Michael, go ahead.
I was going to say, Pascal, I followed along. I don't have a strong feelings about alternatives to your proposal about how to pack them, and I have to think a little bit more about the question about track IDs and their scope. But I think you're bang on that point, though. Probably.
Okay. And what about, you know, supporting a real DODAG like this page says? Basically, this page says we have the VIOs, which are easy to implement, right? It's the root, the main root, which still does all the work. It's just deported. You know, the action is deported to the ingress, but the source route is pre-digested by the main root. And this proposal here is for, you know, the next step where the root, the real root, instead of putting the legs pre-digested, just gives the DODAG itself to the tracking grass, and the tracking grass is free to design source route paths inside that DODAG. So it's more complexity in the ingress, but it opens to row and all that stuff. So should we already mention it, or should we keep it for a different document?
I think if it can be implemented without changes to the original document, then a new document may be better, but I don't have a strong feeling that way.
It's just that the new document will be pretty thin, because what we say is in the PDAO, instead of putting a VIO, you can also put multiple sequence of target transit, which redraw the DODAG. So it's very simple. It's 2 paragraphs.
Okay, well then maybe it's not worth the document then. My only thought was that if it took a lot of thought, think about it, then people might want to have a lot longer opportunity to figure out what to do, and there might be multiple options, and that we wouldn't want to hold up this document. But if it's that short, then okay, never mind.
Well, really, the idea is, you know, when the main root works in non-storing mode, it gets a number of packs target transit, right? That's how all the hops kind of the DODAG are described. A child, several parents. And so to get the exact same result for building a track, all you need is the main route to build those sequences, target, transits, and pack them all in one package as opposed to multiple small packages like you do with the main DODAG, and just send this big pack to the ingress. Now the ingress gets the exact same information as the main route. And so we know it works because that's exactly what we do in the main route. So that's basically the proposal on the table. Now, so we know it works. It's not many words. It's just one more capability for this draft versus writing another draft. We've seen with REPL that doing a V2 it can take very long, and we don't even know if it's going to come. So that's why I want to pack this inside this one. But maybe it's too much, and somebody with a good advice will tell me you need to stop somewhere, and we're already there or something. I don't know. Personally, I would like to pack it inside, but or at least try. And then if the review tell me don't, then I can take it off.
Okay, we need to think this through.
Yeah, please. And, that was my big question to the group. I'm not saying we should resolve it. I wanted to re-discuss that, put the thing on the table in front of everybody during a meeting. Much easier than email. Making sure I'm reaching everybody. So thank you, Dominic. Thank you so much for the opportunity.
Sure. I think people get disconnected and we are largely over time, so we'll call it a day here at least and close the meeting. Thank you everybody for participating, and we'll publish the tentative notes.
Thank you, Torles. I'm seeing Torles. I didn't see him before. I said thank you, Torles, for your review. I'm on it, but now I see him, so I want to make sure I could. Sorry for interrupting.
He was on the call since the beginning. So.
Oh, it was just scrolled down. Okay.
Thank you all. Have a good day. Bye-bye.
Thank you. Take care.